Yeah. Okay, great. So what we're covering today, as I mentioned earlier, just array manipulations. These are some of the questions that I got as a first year student at in Sydney. And also, we're not going to be doing arrays in isolation. So we'll be talking about arrays and just touch on other topics like objects. And this will definitely come in handy with the Java and OOP concept. Sorry, just one second. I'm going to stop my video just because my internet quality is. Sorry. There we go. But yeah, please do feel free to message me in the chat. I'll be checking periodically just to make sure that there are no messages or questions. Or if you want, you can unmute your mic and just share with us what you're thinking or the question that you have. Okay. So now that we've talked about what we're going to do, let's get into it. So consider you have an entire class of 60 students. You want to include their grades in a program you're working on. How do you do this? Do you create 60 variables? And I'm going to throw something into the chat here, actually. Sorry, 1 second. And this is just a playground for Java that you can do online in your browser. So I'm going to open my own up, and I'm going to bring this over here. So if the question basically asks me, like, do I want to, can everyone also, is the font too small? Do you want me to zoom in?
Yeah, if you can zoom in a little bit, amazing.
Okay.
Yeah,
there we go.
Perfect. Thank you.
Okay, great. No worries. So if we wanted our program to record 60 grades, how would we do this? Would we make 60 variables for it? So for example, int G1 is equal to 70, int G2 is equal to 80, int G2, forgive my typing here, is equal to 80, and so on and so forth. Would we do this for 60 grades? Does that make a lot of sense? And the answer is no. And although this is not logically wrong, you'll never run into a compiler error for this. It's a waste of resources. You're essentially typing up 60 lines, making 60 different variables for 60 different grades. And then if you wanted to print out those grades, you'd have to do system.println and then do G1, right? And G2. So that's another 60 lines right there and then. So that would be just like a real waste of time. So this is where arrays come in. And arrays are a really important concept. The more you get into Java, that's my bad. The more you get into Java, simply because arrays are sort of the foundation for other types of collections. So let's talk about this a little bit. So, oopsie, wanted to click play here. So arrays. So what exactly are arrays? Basically, arrays are Java objects that can hold multiple values of the same data type at the same time. So for example, if you have a collection of integers that you want to store within one variable, you absolutely can do that. You have, so here we have 4, 5, 6, 7. We'd put that in an array like this or like this. So as you can see the declaration here, basically what you do first is you declare the data type, declare the variable name, and then put the angle brackets, the square brackets after the variable, and then you can declare it in essentially 2 ways. They're pretty flexible with declaration, initialization. So you can have the curly brackets and then put your values in one at a time. The second way to do this is that you can declare an array of your data type. Now notice here, the square brackets come after the variable name. Java is pretty flexible. You can also put the square brackets right after the data type as well if you wanted to, and then declare the variable name after. And then if you wanted to declare it as, if you don't know these values as of yet, that's totally fine. The only thing you really need to know is the length of your array. So for example, here in this above array here, we have 1, 2, 3, 4 elements, correct? So when we declare, if we wanted to do the same thing with this array, but we don't know these 4 elements right now, we can definitely do that. We just need the new keyword, this int, the data type that we declared here, this angle bracket, and in between that angle bracket, the number of elements that you want your array to hold. And this goes back sort of to memory in Java. So let me talk a little bit about that because this is really important. So when you have memory on your computer, just pretend this is your memory. Forgive my artistic skills here. Essentially, when you store a variable, you just take a piece of that memory. So if I had a variable here, int x, okay, you're just basically telling Java to hold a place in memory for you the size of your integer value, which is what, 32 bits, right? So Java will say, okay, I'll save this 32 bits so you can store your X here. Now, when you write a Java program, there's probably going to be a lot of variables that you have stored in your on your computer. You're probably going to have an integer, another value y, z, a, b, c. Basically, no matter how many variables you store, there are going to be different parts of your memory that's taken up with space. And of course, the size. So if you have a double, right? Oh my God, please forgive my writing. If you have a double and you declare the double as G, because the double takes up 64 bits, it's going to take up twice as much memory as your integer, right? So if I had a double, it would probably take up twice as much. Now, what happens when you declare an integer array? When you declare an integer array, essentially what you're telling Java to do is you're going to store the length of whatever data type that you prescribe at the beginning, the length number of times. And these points in memory, they're always going to be beside each other. So if I wanted to initialize an array with the values 4, 5, 6, 7, I can't just take this point and this point and this point and this point. Arrays don't work like that. They have to be beside each other in memory. So that's where if I declare an integer of, if I declare an array of length 4, my Java compiler is basically going to try and find a place in the computer where I can put 4 integers right beside each other. So here, 1, 2, 3, 4. Now, can someone tell me if I wanted to change the size of this array, can I just make it integer? Can I do this? Can I go int array equals new int 5? And I'll take a look at the chat for that. Can someone tell me? I'll keep them for now. Can I do that? And take a guess. You don't have to do it. What was that? Sorry?
You can repeat the question?
Sure. Can I just redeclare this array that we have, that we put in memory for 4 integers? Can I redeclare that to have a length of 5?
Yeah, I want to say yeah.
Good try. So I'll show you how this works. So essentially, because we're working with arrays and they take up a specific amount of space, we can't just add spots in memory according to our whims. We can't just say, oh, yeah, just randomly make up an extra spot in memory beside the rest of the elements of the array. We can't, and because of that, we can't rearrange the size of this array. Once we set the array size, we can't just randomly make up spots in memory to increase the size of that array. Does that make sense? This won't work.
Okay.
Yeah. Is everyone with me so far?
Yeah, so if you want to create a new array, you would have to literally create a new like int array and then put whatever in there?
Exactly.
Okay.
Yeah, you hit the head on the nail, the nail on the head. It's exactly that. So if you ever wanted to increase the size of an array, because we can't play God with memory, we essentially have to find a new spot in memory. So let me expand this. A new spot in memory that has the size that we want. Okay, so pretend here. Get this. We can reserve a new spot in memory that has the size that we want, and then copy these elements from the first array into the second array. So we'd have to completely have a whole new array if we wanted to extend the size of an array. Okay, is that making sense to everybody?
Understood.
Okay, great. So now let's talk about primitive types can only hold on to one value at a time. And this makes sense. So do you remember what I told you about last time when you store an integer in memory? basically you're only saving the amount of space in memory that the size of an integer is. Same thing with a double. So primitive types that include integer, double, float, Boolean, that sort of thing, it will always hold on to the same amount of memory that is pre-declared at a time. So for example, if you say this x is equal to 9, it will always only take up 32 bits in your space and set that to 9. Okay. And the reason, I'll get into why this is important, because arrays can also hold objects. So if I created my own object, so for example, like a student class, and I gave that student class a, I don't know, a name, which is a string, an age, which is an int, and a, I don't know, past as a Boolean. Basically, with each element, if you make an array of student, each element that will be stored into the array, it will take up exactly the amount of space that you need to make an object of student. So for example, I don't even know what I wrote, the name. Okay, so string, it will just depend on the size of your character. I think I can't remember exactly how much it is, but so let me just change this to like, I don't know, I'll just erase string. So int, let's say 32 bits, and pass Boolean 8. So every student will always hold 40 bits inside of your memory. Now you might be wondering why I'm talking about memory. This is really important to understand larger concepts of collections like array lists, because I know it will get more complicated than that. I just hope to give you the foundation right now if you haven't already received it, or as just a reminder. So let's do an exercise. Okay, so we have an exercise here, and basically I'm just declaring, oh, this is wrong. I'm declaring an array of integers called grades, and I'm making the length of my integer array 10. So can someone tell me how many elements I have within my integer array? Oh, yeah, sorry, I didn't see the name there. It's the question there. Array can't be altered. No, the size can't be altered. If you wanted to change the size of an array, you'd have to create a new array completely and then copy the values from your previous array into that new array. Okay, so again, I'll ask, does anyone know how many elements we're storing if we declare, using this declaration? 11, close. Thanks for participating. Basically, it's, so we're storing 10 elements here, but since arrays are 0 indexed, we're gonna call the element starting from 0, 1, 2, 3. So if you count these, you're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You're going to get 10 elements in total. However, whenever you want to access one of those 10 elements, you're going to access the element at whatever position minus 1. So if I wanted to access the fifth element, 1, 2, 3, 4, 5, I'm going to have to call grades at index 4. Is that making sense? Yeah, 10, exactly. Okay, feel free to stop me if I'm just rambling on. Okay, so let's talk about the next thing. So let's talk about this. So we saw before that our indexes start at index 0 and they go all the way down. They increase by 1 until they reach the end of, They increase by 1 until the last index, which is going to be the number of elements minus 1. Okay. So this is going to be index 0, index 1, index 2, index 3, index 4, 5, 6, 7, 8, 9, 10. 8, 9, not 10. Okay. So can someone tell me if I wanted to set index 1 equal to 70, where would I put this 70?
In the second box?
Yes, that's perfect. Yes, exactly. So I'll go ahead and put that there. Now if we move on to the second line, where would I put index 5 with value 100? Sorry, I have to keep exiting and re-entering my presentation. Well, let's count through it. So we know that it's at index 5, and we know that the first box is index 0. So it would be 0, 1, 2, 3, 4, 5. This one over here. So I'll just go ahead and do that. Oh, this is much easier to type in. So 100. Okay, now what about this one? Grades at index 1. Well, we already said this grade's at index 1 to 70, correct? What happens if we reassign the value? I already just said, yeah, exactly, the sixth one. Perfect. What happens if we reassign the value? Maybe error? Ooh, close, close. Because these are, yes, exactly. Thank you, Winsop. So you get, basically, it's like redeclaring. So for example, if you have integer x is equal to 0, and I say x is equal to 1, will I get an error? And the answer is no, because you can reassign values of integers, no problem. So with arrays, it's the same principle. If you have an integer stored at index 1, which is valued at 70, you can just replace that 70 with the new value, which is 95. Okay, so let's move on here. So we have a new integer. We're calling it I, and we're setting it, we're setting it to 8, to the value 8. Now, what would grades be at index I? Where would I put this in this box? Well, let's think about this. So if I is equal to 8, basically we're saying put grades at index 8, put grades at index 8 equal to 85. And so we count through the boxes 0, 1, 2, 3, 4, 5, 6, 7, 8, and would make it 85. Okay, now if we increase I, so I is 8 over here. And if we increase I by 1, I is now 9. Where would I put this 90? Could someone tell me? The last box, exactly. So we put 90 over there. Now, can someone tell me what would happen if I did grades at index 10 equals, I don't know, 50? Does anyone know? Yes, exactly. Because we haven't kept space in our memory for that extra value, we're going to get an index out of bounds error. It doesn't exist in memory, therefore you can't assign a value to it. So this is definitely going to return an error. So I think you guys get this really well. Now let's talk about this. So let's go ahead and do this. So consider this. You have inputted all of your 60 students' grades into an array. How do you display all that information? Do you write system out print line? So let's go back and let's change this to 10 students, just because that's a lot easier to work with. So you have 10 students, and you want to put them in an array. So can someone help me out here? How would I do that? And let's assume here that the grades that we're working with are all integer values. So first of all, we'll declare the type, so int, and then we'll make sure that we have the angle brackets, so we know that it's an array of integers, and then we give the variable a name, so grades. And then there are, of course, many ways to do this. I'm just going to do this in the easiest way. 1, 2, I don't know what kind of class this is, but it's going to have grades of 1, 2, 3, 4, 5, or whatever my finger finds on time. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 grades there, correct? Now, if I wanted to print out all these values in this array, the question is asking me, would I do system out print line for each value of the array? Does this make sense?
No. You
No,
just put grades in the parentheses.
Oh, close. Good try. It's close. So if I wanted to print out all of these grades, I'd essentially have to repeat this X amount of times. I don't know. 1, 2, 3, 4, 5, right? Now, with coding, the general principle is that if you see any repeats, there's probably a better way to do it, especially if there's only one thing changing. Can someone tell me what the only thing changing between these 4 lines is? Yeah, exactly, a loop. It's just this variable here. Everything else is the same. You're still accessing the same array. You're still performing the same function on it. So there usually is a better way to do something like this. So this is just like something to keep in the back of your mind. If you ever see repeats, there's probably a better way to do it. So here's where we're introducing the concept of a loop. Okay. So basically, a loop is a form of iteration in which you can step through your array one by one, or by whatever interval you choose, and do anything you want with whatever index you're accessing. So for example, if I go back to our array here, and I wanted to print out each of the values in this array, I'd start off with my for statement, and I'd initialize a counter. So in our case, our counter is index I, and I want to specify a condition that will basically tell my for loop whether or not to continue. So if I have my index I set to 0, I want to make sure that my I hits all the values within this array. So it would be index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we want to make sure that I is equal to all of these values here at some point in our loop. So in order to ensure that, we can say, and also here, if you notice here, we have 10 elements. So we can say the condition that we want this loop to continue is that our counter must be less than the array length. Because we have 10 elements here, we want to make sure that I is 9. If I is 10, then we're going to get an error. So we don't want our loop to continue that far. We want to make sure that it stops at 9. And then, of course, we need a statement to make sure that our loop is incrementing one by one. Okay. So if I do a system out print line here, and I put in my grades, I'm going to be printing out my grades at index I, and I run it, you can see that I'm printing out all the grades starting at this index all the way to the last index. If I say I is less than or equal to grades.length, what I mean by that is if I is less than or equal to 10, we're going to get an error because we have 10 elements and only 9 indexes. So if we try to go for index 10, we're going to get an index out of bounds error. There we go. Okay, so always make sure the I value is going to be 1 less than the length of your array. Okay, is that clear to everyone? Any questions so far? Okay, perfect. Now, the best thing with for loops is that you don't have to specify, you don't have to increment one by one. So for example, if I only wanted to get the even indices of my array, so like 0, 2, 2, 4, 6, 8. If I wanted to print out only the even indices, I can absolutely do that. I just need to set my increment value to a different value. So if I tell I to increase by 2 every time instead of 1, it will, I can show you here. I'll print out I as well. Okay, so if I tell I to increment by 2 every single time instead of just 1, it will skip over a value and print out my even indices. Okay? See, 0, 2, 4, 6, 8. So it's pretty cool. You can do a couple of things with for loops. You can take this even further. If you wanted to find values within even indices that were divisible by 3, you can add an if statement. So if I mod 3 is equal to 0, we should only get, now add in those brackets. You don't have to, but I guess it's just easier to look at. I'll just also add in this so it's more clear. You can see you should only get 2 values because within your array of even indices, only those that are divisible by 3 with a mod of 0 should be printed out. So if you take a look, index 0, index 6, 1, and 7. So is that clear to everyone? You can do a lot with loops that way and arrays. Yes. Yes, clear. Okay, perfect. Okay. So let's go ahead and do that. Let's do a for loop just for our grades. So we want to print out every single grade for every single student. So we definitely want to increment by only 1 because we want the 1. We don't want just the even indices, right? 3, 4, 5, 6, 7, 8, 9. Okay. And then for each of those indices, we want to print line, sorry, student plus grades at whatever index I is falling on. Okay, so from 0 to 9, we'll print out student and grades. Now, can someone tell me if the school, like in our array, the first student is always going to be at index 0. But if you're at a school and they don't have a student, they only start students at index 1, what would I type in here? Oops, student. What would I type in here? So that I would always be printing out the student numbers, the student number starting from index 1 as well. Because I'll show you right now. If I type in student I right now, it's going to say student 0, 1, 2, 3, 4, 5, 6, 7, 8. Oh, no. Sorry, here we go. If I type in student I, it's going to start at index 0. But if I wanted this index to start at 1, what would I make this value equal to?
You'd make it equal to 1?
Oh, close. Because, so if I do that, let's see what happens. Okay, I is equal to 1. Sorry. So this stays I. You're talking about this I, right, Winsome? Yeah, okay. So let's run that and see what happens. So you get 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we're missing a student here because if you count this, it's only 9 students. So can someone tell me what happened? Does anyone know? Well, let's take a look at these integers here. So you see how 2 is here, like the first value that we're looking at is index 1 if we set I equal to 1, correct? Yes, exactly. Index 0 is missing. So that's a problem with doing it that way. So it's always best to start at your first index unless you actually want to start from the second index. Okay. So the way that you could do this is actually manipulate the value of I that you print out. So without changing the value of I, you can say you can print out the value of I plus 1, which will not change the value of I. It will only change whatever is being printed to the console. So if I ran it now, we get all 10 students. So we should get another line here. Yeah. And you can see the index has increased by 1. Okay. So just something important to keep in mind. So if you want to, like, if you don't want to change your counter to manipulate the output, make sure to manipulate the output in such a way that you don't like change the counter itself, but you change what's outputted to the console. Does that make sense? Does someone need clarification? Yeah, okay, great. Great. Okay, so now let's do a question I believe I got in first year Java. Yeah, this is some fun stuff. So you're given a list of temperatures over the month of August. You want to find the average temperature of the month, the maximum temperature of the month, and the minimum temperature of the month. Use arrays to do this and print out all your results. So I'll take these values and I'll put them into the chat just so that no one has to type these out one by one. Okay. And let's go back to our playground here. Okay, and I'll get rid of all the student stuff. And let's talk about what we have to do. So first of all, we're given in a bunch of temperatures, right? We want to find the minimum temperature. We want to find the maximum temperature. Oopsie. And then we also want to find the average temperature. How would we go about doing this? Well, talking about this, the first thing that we would do is we probably, tell me if this makes sense. Temp 1 is equal to 33, and temp 2 is equal to, I don't know, 44. It's a hot day that day. Does this make sense, what I'm doing? Is this the best way to? No, exactly. It's not wrong. It's just very tedious and very long. So I'm going to make an array instead and make sure that collectively all my values are stored together in my memory. So I'm going to call this array temperatures. And I'm going to make it equal to curly brackets. And everything should be formatted for you. Hopefully, I don't want you to go through and reformat anything. You can just put all those values within curly brackets after the array declaration and should be good. Okay, so once you have your array, what's the next step? Can someone tell me? Well, first of all, I know this is grade school math, but with average temperatures, just for those who need a refresher, basically for average, you're going to have to add all the temperatures together and then divide by the number of elements that you have. So, so total of temperatures divided by number of elements. Now, do we have any of these variables? Do we know any of these things? Well, to find the total of temperatures, we probably have to go through each one and add them all together. But if we wanted to find the number of elements, we can definitely go ahead and do that. We can access. Does anyone remember how to access the number of elements of our array of temperatures? It's okay. It's basically you just access temperatures dot length by index. Oh yes, thank you. Yes, exactly. I don't think it's a property, right? Should run, not an actual function. Yep. Yeah, there we go. Okay. So we have the total number of elements, but now we just need to. We have the number of elements. Now we just want to find the total sum of all the temperatures. So can someone tell me how we go about and do this? I'll give you a hint. We just looked at it a little bit earlier. Well, if we were to do this logically, step by step, if we were to punch this into our calculator, we do 33 plus 25 plus 27 plus 20 plus so on, plus so on, plus so on, plus so on. Now, how could we do this in code? How do we loop through each of the indexes? No takers? Okay. Okay. Well, first of all, I'll create a variable to store this value that we want to save. Is equal to 0. And remember, if we want to step through an integer, or if we want to step through an array, each of the elements of an array, we can do a for loop. So again, we're going to need our counter. We're going to need to make sure that our counter never exceeds the number of elements of our array, and we're going to need to increment our counter. Is that making sense to everyone so far? Does anyone need any clarification? No clarification? Not making sense? Sorry, I should have asked one question at a time. Is it making sense to everyone? Clear. Okay, perfect.
So with the sum, would you put like in, hold on, I think would it be in sum equals 0 plus 1? I don't know.
Oh, okay. So I haven't exactly gotten into the sum yet, but we know that when we want to find the average of any number of elements, we just need to make sure that we have the sum of all the elements. So we need a variable to store 33 plus 25 plus 27 plus 20 and so on and so forth. Does that make sense? I just made sum equal to 0 for that purpose later on. Does make sense? Makes sense. Okay. So let me start off with just the average. Okay, I'll just work on the average for now, and then I'll come back to minimum and maximum temperature. So for the average, we know that we're going to want to make the sum equal to whatever index of I. We want to basically add up all the indexes here into a total value, correct? So we know that we're accessing each element with each element of the temperatures array with each iteration. And so we are just going to add to the sum the value of the temperatures array at that iteration. So for example, when the sum is going to be equal to sum plus temperatures at iteration I. So for example, when I is equal to 0, which is 0, is less than 30 for sure, so we can continue our loop. We are going to say sum is equal to sum, which at first is 0, plus temperatures at index I, 0. So we're going to say, so the first iteration, sum is going to be equal to 33. Then we increase I. So I is now going to be 2. I is going to be 1. 1 is less than 30, so we continue our loop. And sum is going to be sum, which is 33, plus temperatures at index 1, which is 25, which is then equal to 58, I hope. I don't know. That doesn't look right. 58. I'm going to go with that final answer. And you keep, basically, this just makes sure that every time you step through the loop, you're adding to the sum the next index value. Does that make sense to everyone? Okay, please stop me if it's not clear. I know, I'm sorry, I'm not very coherent today, but let me know if anything isn't clear. Okay, so once we've stepped through this array, once we step through every single value of this array and we've added everything up, to find the average, all we have to do is take sum and divide it by our num of elements. And then we can just print that to the console. Average plus average. Then we can see our average temperature there. It's going to be 25 degrees Celsius. Okay, so for the average, is that making sense to everyone? Yes. Okay. So now let's move on to the minimum and maximum temperatures. Now these ones are a little bit trickier, but basically how we're going to approach this is that we're going to try. So first of all, we're going to need a variable to tell us what the minimum temperature is. And I'm going to make this variable equal to integer.max. value. And same thing with the max. We need a variable to store the max value that we want to work with. Now, just looking at this array, just eyeballing it, I think our max value is 37, I saw? Yeah, 37. So we're supposed to get 37. And our minimum value is going to be,
Maisie?
I think I saw, yeah, I saw 10.
Mhm. Yeah, just could you change the variable name? You switched, like, yeah, min should be line number 15.
Minimum?
No. Like integer dot max value should be min value because this is minimum, right?
Wait. I'm sorry, could you repeat that? My
No?
internet was wonky. What was that?
So like int minimum equal integer dot max value should be minimum value, right?
No, I'll get
We're
into
getting
this. I'll show you how
Oh,
this.
okay.
Yeah. Thanks for bringing that up. So I'll explain why we're doing this. So if you have a minimum value and you want to set it to the absolute maximum value that it could possibly be. So with integers, I think it's like 200 million something, 2 million something.
Oh, okay. Yeah. Oh my god,
Yeah.
I forgot.
No, I know it confuses me all the time too. With your integer minimum value, we
Right.
want it's equal to negative 200 million or something. The reason why you don't ever want to set your minimum or your maximum value equal to 0 is because you don't know what's inside your array set. Because, for example, if I had an array with -2, -3, and -4, and I loop through that array, comparing any value inside my minimum, inside my array to the minimum value. Oh, sorry, this is backwards, isn't it? Yeah, sorry, +2. So if I had an array with values 2, 3, and 4, and I set my minimum value to 0, basically what happens is I'm going to compare 2 to 0. Obviously 0 is less than 2, so my minimum stays at 0. I compare 3 to 0, and 3 to 0, and obviously 0 is less than 3, so my minimum value stays 0. I compare 4 to 0, of course 0 is less than 4, and so my minimum value stays 0. However, 0 doesn't exist within the array itself. So it's always important to make sure that you set your minimum value to the maximum value an integer can hold. So that way, so for example, for the first one, if I compare the two, so if I set this to 0, let me show you what happens if I set this to 0. Okay. If I set this to 0 and I compare 33 with 0, what's less, 33 or 0? Definitely 0, but 0 doesn't exist within our array set. So that's why it doesn't make any sense to make it an arbitrary value. It's always important to make it something like the maximum value. So now if I compare 200, like, I don't even know how many is it, 2 million with 33, for sure 33 is going to be less. So that's going to be our new minimum. Same thing with the max value. It's just in reverse. You always start off with the absolute lowest value so that whenever you do a comparison, whatever is it within your array will automatically set the basis of what's going to be compared. Does that make sense to everyone? I know it's a little confusing. Yeah, okay. Perfect. Okay. So now, oh, still not understanding. Okay, so let me go through that one more time. Okay, so pretend I set this to 0. Okay, the maximum to 100. Okay, if I use the minimum value at 0, if I set the minimum value at 0, if we look at our data set, there are no values equal to 0, correct? There are no values equal to 0. But however, because the way we're implementing this, we want to compare any value within our data set against the minimum value. So for example, if I compare 33 with 0, we know that 0 is less than 33, so the minimum will stay at 0. If I compare 25 with 0, we know that 0 is less than 25, So the minimum will stay at 0, and so on and so forth. There's no value in this data set that is less than 0. However, the value 0 itself does not exist within this data set. It doesn't exist. And so logically, that doesn't make sense. How can our minimum temperature be 0 if our temperature never hit 0 in August? Does that make sense? That's why we set it up. We set it to integer dot max value. So that, which is technically equal to 2 million something, positive 2 million something, so that whenever we do our comparison, whatever we get within the array, so 33 compared to 200,000, 33 is definitely less than, 33 is definitely less than 2 million, correct? And so minimum will now point to this 33 as its new minimum. Then when it gets to the next one, because minimum is now 33, it will compare 25 with 33, and so on and so forth. Does that make sense now? I know it's a little bit confusing. Okay, great. And the same thing with maximum integer, but it's just in reverse. So we want to set it to the lowest possible value that we can, so that it can only increase. Now, in order to get the minimum and maximum values, first of all, let's start with minimum. So min. So in order to do a comparison, we can use math.min comparison. And basically what this function does is it takes in two numbers and returns a number that's smaller. So we can compare our min from before with the value at our temperatures at index I, and we can get the smallest temperature from that. Sorry. Okay. And so once we loop, so for example, with the first one, we'll compare 200,000 with 33, because min at this point is, 2 million with 33. Min at this point is equal to 2 million, and we'll compare it to 33. We're going to return 33 because it's smaller than, it's the smallest of the two values, and we'll set the new min to 33. With the next iteration, we'll compare 33, which is the new value of min, to the temperatures at index 1, which is 25. And then min will be equal to 25 because it's smaller than 33. Does that make sense? 3 minutes left. Oh boy, okay. I know we can do this. I just want to spend time explaining. For the maximum temperature, let's do the same thing, except instead of using math.min, we're going to use math.max. And we're going to compare it with the maximum value because we're looking for the max. Okay. And then we can just, so this will essentially loop through the array list, the array, and it will compare the values with the previous minimum. If it's smaller than the minimum, then it will change the minimum value. If it's larger than the minimum, it won't do anything. Same thing with the max. If the value we're comparing is larger than the maximum value, then it will change the maximum value, and so on and so forth. Then when we're done, we can just print everything out. Minimum, and we can change this to min. And maximum. And we can change this to max. So this is a question I got in first year. There's another question on that slide. So as we can see, exactly what we thought it would be. Minimum is equal to 10 degrees, and the maximum is equal to 37, because it takes the largest of the values that you compare. So is that making sense to everybody? I know it was a lot to cover within just like 5 seconds. Yes. Okay.
Maisie, you can explain the int min equals integer dot max value. What's the purpose of the? Explain the integer dot max value for me.
Oh, okay, sure. Integer dot max value essentially takes the largest possible integer that you can ever create ever. So with 32 bits, you can create an integer value of like 2 million or something. Let's see here. Integer max value. What is it? Yeah. Oh, sorry, more than 2 million. It's like 2 billion. Right there. So this is the integer max value that you can possibly create. So if you have an integer, this is the cutoff point. If you have a value larger than this, it's no longer an integer, it's a double. Same thing with min value. This is the smallest possible integer that you can have. If there's a value smaller than this, it's a double or a float or something, some other data type. Does that make sense? Yes, no. I know we don't have a lot of time. Yep. Okay. Okay. I had one more question. I didn't realize how long it was going to take. If you want, I can put it in the chat later and you can practice it. It's a little bit harder. I also had this in my Java 1 class. But yeah, so I'll just stop. Are there any questions and comments? I know we only have a minute left. I don't know if it's going to cut us off. So.
I don't know too. Do you want to test it?
Yeah, actually,
Oh,
we're still here.
Yeah, just to get us the
Okay.
premium account, so
Okay.
maybe we can go over a bit. But I can stop recording for now if
okay.
that's all we have.
Okay, I'll stop
Let's wrap
presenting
it
as well. Sure.